Hello everyone, myself Preeta and I'm going to explain about OpenGL Quadrics surface. What is OpenGL Quadric surface? A frequent used class of objects are the quadric surfaces which are described with second degree equations quadrics. They include spheres, epilioids, torus, parabolites and hyperbolites. Quadric surface, particularly spheres and epilioids, are common elements of graphic scenes. Okay, what are spheres? A spherical, a spherical surface with radius r centered on the coordinate origin is defined as a set of points x, y, z that satisfy the equation x2 plus y2 plus z2 which is equal to r2. We can also describe the spherical surface in parametric form using latitude and longitude angles as shown in figure x, which is equal to r cos phi cos theta minus pi by 2 less than or equal to phi less than or equal to pi by 2, y which is equal to r cos phi sin theta minus pi less than or equal to theta less than or equal to pi z which is equal to r sin phi. Alternatively, we could write the parametric equations using standard spherical coordinates where angle y is specified as the co-latitudes as shown in figure. Epilioids. An ellipsoidal surface can be described as an extension of a spherical surface where the radii in three mutually perpendicular directions can have different values. The Cartesian representation for points over the surface of an epilioid centered on the origin is, and a parametric representation for the epilioids in terms of the latitude angle phi and the longitude angle theta. Rx which is equal to Rx cos phi cos theta minus pi by 2 less than or equal to phi less than or equal to pi by 2, y which is equal to Ry cos phi sin theta minus pi which is greater than or equal to theta greater than or equal to phi, z which is equal to Rz sin phi. Torus. A torus is a donut shape object as shown in figure below. It can be generated by rotating a circle or other conic about a specified axis. The equation for the cross-sectional circle shown in the side view is given by yr axial of 2 times plus z2 which is equal to r2. Rotating this circle about the z axis produces the torus whose surface positions are described with a Cartesian equation. The corresponding parametric equations for the torus with a circular cross-sectional r x which is equal to x axial plus r cos phi cos theta minus a pi less than or equal to phi less than or equal to pi y which is equal to r a axial plus r cos phi sin theta minus pi less than or equal to theta less than or equal to pi z which is equal to r sin phi, which we could also generate a torus by rotating an uh, instead of the circle about the z-axis. We can write the ellipse equation as where r axial is the distance along the y-axis from the rotation z axis to the ellipse center. This generates a torus that can be described with a Cartesian equation. The corresponding parametric representation for the torus with an elliptical cross section is x, which is equal to r axial plus ry cos phi cos theta minus pi, which is less than or equal to phi less than or equal to pi, y, which is equal to r axial plus ry cos phi sin theta minus pi less than or equal to theta less than or equal to pi, z, which is equal to r z sin phi. So let's conclude what is open-gel quadric surface. An open-gel quadric surface is a used class objects that are quadric surfaces which are described with second class degree equation quadrics, which include spheres, ellipsoids, tori, and paraboloids and hyperboloids. Spheres are a spherical surface with the radius r centered on the coordinate origin. We can also describe the spherical surface in parametric form with longitude and latitude. Ellipsoids. An ellipsoid surface can be described as an extension of a spherical surface where the radii in three mutual perpendicular directions can have different values. The Cartesian representation for points over the surface of an ellipsoid centered on the origin is torus. A torus is a donut shaped object. It can be generated by rotating a circle or other conic about a specified axis. Rotating this circle about the z-axis produces a torus whose surface position are described with a Cartesian with a Cartesian, and we could also generate a torus by rotating an ellipse instead of a circle about the z-axis. We can write the ellipse equation as this generates a torus that can be described with the Cartesian equation. And this is all about open gel quadric surfaces. Thank you.